Hello, and welcome to the 9th lecture, in which we discuss the article by Gerald Katz, The Unfinished Chomskyan Revolution. Ostensibly an article about linguistics. Well, of course, it is an article about linguistics, but the points which Katz makes can also be applied to the cognitive anthropology that we've been discussing. We've been discussing a computational approach to sociality, a computational approach to language, and a computational approach to counting. And these hypothesized computations are supposed to be, we've considered them to be, actual processes that occur in the brain. But here's a question. Is it possible that we've been looking in the wrong place? Could it be that relational models, or numbers, or sentences, or all of those things, are best construed as abstract objects rather than products of anything going on inside the brain? Now, according to Katz, the discrete infinity of language and the discrete infinity of the natural numbers means that sentences, and numbers for that matter, are abstract objects. They're not brain processes. And note that analogous reasoning would apply to the relational models because the social relational models also exhibit discrete infinity. Now, the first question we have to address is whether or not discrete infinity has any metaphysical implications, which Katz believes that it does. By metaphysics, I mean questions of matter of fact which cannot be decided empirically. So, for example, Platonism is a metaphysical viewpoint. It's the view that there are abstract objects. And abstract here means existing outside of space and outside of time. And this implies existing independently of thought, because thoughts at least occur in time. Thoughts may also occur in space. If you identify the mind with the brain, then a thought is a brain process and it occurs in space. But even if you don't identify the mind with the brain, you have to acknowledge that thoughts at least occur in time. So if something is independent of space and independent of time, then it is also independent of thought, which abstract objects are by definition. Mathematical Platonism is one form of Platonism. It's the view that there are mathematical entities which have abstract existence. So, for example, one could argue that Platonism is true of natural numbers by reason of the natural numbers exhibiting discrete infinity. Discrete here means corresponding with the natural numbers, in other words, being digital. Infinity means infinity, so the natural numbers exhibit discrete infinity. Nothing in space-time exhibits discrete infinity. And facts about natural numbers are independent of what people think. Therefore, so the mathematical Platonist argues, therefore, natural numbers have a non-psychological reality outside of space and time. Now, a very similar issue is debated in linguistics, or more properly in the philosophical foundations of linguistics. Namely, the question of whether language is a natural object, which is the working assumption of what is called biolinguistics. Biolinguistics is the paradigm in which Noam Chomsky works. Yeah? So that's one possibility, that language is psychological and ultimately biological, given that psychology is ultimately neurology. The other possibility is that natural language is an abstract object. And this would imply that linguistics is a branch of pure mathematics and hence a purely formal inquiry. In other words, it's not empirical according to Katz. Linguistics is a priori. It's based upon reason alone and not observation. Now, let's review discrete infinity a bit. We've talked about this already. According to Noam Chomsky, the most elementary property of the language faculty is the property of discrete infinity. You have 6-word sentences, 7-word sentences. Those are natural numbers, of course, 6 and 7. But you don't have 6.5-word sentences. So you don't count the constituents of a sentence using fractions. That's the discrete part. Furthermore, there's no limit. That's the infinite part. You can have 10-word sentences, 20-word sentences, and so on indefinitely. What appears to be the most common argument for the indefinitely recursive nature of language is to observe that attaching a finite number to language would be arbitrary. And this point was made before Chomsky by Chomsky's teacher, Zelig Harris, who noted that one cannot set up a reasonable description of a language that implies its being finite. Any attempt to do so would have to place a limit on some recursive operation, such as, for example, the number of times that the word "and" can appear in a sentence. And any stipulation like that would be highly arbitrary and numerical. That's a quote from Zelig Harris. Highly arbitrary and numerical. Now, a more explicit formulation of what I understand to be the same argument is found in Paul Postel. Postel notes that any attempt to posit a finite bound, let's call it M, any attempt to posit a finite bound for sentence length faces two challenges. The first challenge is, why should the bound be M and not M plus 1? If it's impossible for a sentence to be longer than 15 words, why 15? Why not 16? The second challenge, essentially the same challenge, is what argues that the bound is M and not M minus 1? If someone insists that a sentence can have no more than 15 constituents, why not 14? Okay? And Postel goes on to note that there is no non-arbitrary way to pick M that justifies it against either a smaller bound or a bigger one. Okay? And Postel has also observed that one cannot argue for the finitude of language by placing a vague bound on sentence length. A vague bound. Because challenges that are analogous to 1 and 2 on the screen would also apply in the case of vagueness. In other words, an approximate bound is just as arbitrary as a unique bound. Now, of course, there's some sense in which one could put a non-arbitrary cap on sentence length. The question is whether that sense is relevant to devising a theory of grammar. Okay? And so, what are we talking about? Well, we're talking about performance limitations, the sort of thing that was discussed in the lecture on George Miller. For example, constructing a sentence takes time. The human being is mortal. We don't have all the time in the world. And even all the time in the world would be finite. Mortality constrains how long a sentence can be. Short-term memory limitations also place limits on the number of nested embeddings in a sentence. That was Miller's point. This is just to say that performance limitations are removed when we infer that language exhibits discrete infinity, in other words, indefinite recursion. Whether it's rational to factor them out is the question at issue. Is it rational to factor out performance limitations? Now, social relational cognition, insofar as it's structured by the relational models, also evidently exhibits discrete infinity. In other words, indefinite recursion. So part of the complexity of social life is a result of the recursive embedding of one instance of a relational model within another instance of the same type of model. So Postel's argument for indefinite recursion in language can be applied analogously to relational cognition. As such, it's a challenge to anyone denying that the models exhibit discrete infinity, the Fiske's relational models. Now, turning back to the subject of language again, Let's consider the history of linguistics. Many issues which arose in the history of linguistics also apply to relational models theory. Consider empiricist psychology. This is the view that the mind is wholly a product of its environment. Earlier empiricists' approaches to language could not account for the infinitude of language. In other words, one could not account for the infinitude of language by assuming that language is learned wholly from one's environment. Now, when Katz in the article discusses Bloomfield, he's discussing Bloomfield because Bloomfield was a psychological empiricist, and Chomsky's linguistics were an alternative to Bloomfield. It would be a little bit simpler, in my view, to discuss Ludwig Wittgenstein instead of Bloomfield. The points which Wittgenstein raises are essentially the same as were made by Bloomfield, but Wittgenstein is a little bit more direct and straightforward. Okay? So, Wittgenstein suggested in his Blue Book that a child learns language by means of drill. Okay, these parts are in quotes because these are actual quotes from the Blue Book. Wittgenstein suggested that a child learns language by means of drill and training, in the sense of animal training, specifically by means of example, reward, punishment, and such like. Now, Wittgenstein's approach is empiricist in the sense that it views the child's language ability as wholly due to molding and shaping by the environment. Now, Chomsky rejected this view. It's perfectly analogous to Chomsky's rejection of Bloomfield. Chomsky complains against Wittgenstein that appealing only to drill and training makes it very difficult, if not impossible, to explain the child's ability to understand some simple new sentence. And so it's not a surprise that Wittgenstein made no attempt to account for the ability to understand new sentences. If language results from training and drill, then one would expect the child to learn nothing more than how to parrot or respond properly to a sentence that was already learned. But instead, what you find is that the child can produce and process sentences never heard before. Positing mental computation, in other words, recursive thought, by contrast, this can explain unbounded productivity. So, in other words, Wittgenstein could not explain the infinity of language by saying it's the result of training and drill. That's the problem with empiricist psychology. Empiricist psychology cannot explain the infinity of language. Now, as Katz pointed out, Chomsky, in contrast to Wittgenstein, arrived at a more plausible conception of language by positing something less empirical than the immediately observable, namely mental computations. So Chomsky's conception of language is more abstract than Wittgenstein's because it's less directly connected with immediate perception. For Wittgenstein, language is something you just see and hear. You see the person moving their hands, you hear them talking, well, that's language. A very public conception of language. Chomsky moves language inside the head, so it's less directly observable. That's what Katz means when he says it's less, or rather it's more abstract. However, Katz insists that Chomsky does not go far enough. Katz insists that an even less empirical approach is needed to account for discrete infinity. Katz's article is called The Unfinished Chomskyan Revolution because it was Katz's view that Chomsky's conception of language should be even more abstract than it is. Language is completely non-empirical for cats. It's wholly abstract. Language is Platonic. It lies outside of space and time, and language exists by necessity, not the result of biological evolution, not the result of culture. Language is an abstract object like a number or a set. Now, for cats, given that space-time is not infinitely extended, and given that there are only finitely many particles and a finite amount of energy, only something that's outside of space-time could have the property of discrete infinity. Therefore, language is not located in space-time. And language is not psychological, because any given mind is finite, which means that language extends beyond the capacities of any given mind. Even the totality of minds collectively are finite. So language extends beyond the totality of minds. By the way, this point here does not apply to continuous infinity. A finite region of space containing finite matter or finite energy is, even so, infinitely divisible by reason of being continuous. And that's a point that we'll get back to later. I have more to say about that. But just for now, bear in mind that to say that language is discretely infinite is not to say that it is continuously infinite. Discreteness corresponds to the natural numbers. Continuity, by contrast, corresponds to real numbers, such as, for example, fractions. When we talk about the infinity of language, we're not talking about fractions. We're talking about the finger numbers, digital numbers. Now, let's consider some possible objections to cats. Let's consider an attempt to defend the view that language is psychological and ultimately biological. In other words, the language is empirical. Now, Katz asks the following rhetorical question. Given that the sum total of all brains can only generate a finite number of sentences, what does it mean to say that language exhibits discrete infinity? Now, one could begin by suggesting, and this would be the anti-Platonist view, one could begin by suggesting that the infinity here is an infinity of types, whereas the finite set, consisting of concrete expressions generated by a concrete language faculty, is a set of tokens. In other words, when linguists say that language exhibits discrete infinity, they're talking about types, not tokens. Well, what are types versus tokens? What's this terminology about? The distinction between types and tokens was originated by Charles Sanders Peirce, who may have been a bit older at the time than he was in this picture when he had the idea, although I don't really know. Now, the distinction between a type versus a token can be illustrated by asking a simple question. Look at the screen. Now, how many words are on the screen? Seems like a simple question, right? How many words are there? I suppose that you will either say 1 or you will say 2. If your answer is 1, then you're referring to a type. If your answer is 2, then you are referring to tokens. A single type can be instantiated in many tokens. In other words, a type is something which can be repeated. So, for example, there are many instances of the word the, but as a type, there is only one the in the English language. So there's a many-to-one mapping of tokens onto types. So can we say that the infinity of language is an infinity of types, but not tokens. In other words, that language is infinite in the sense that there's an infinite number of sentence types, even if not an infinite number of sentence tokens. Katz's response is, yes, we can say that. But if you say that the infinity of language is an infinity of types, you are not avoiding Platonism at all, because types are abstract objects. A type has no space-time location. If you're committed to the reality of types, then you are committed to the reality of abstract objects after all. And Katz drives the point home by quoting the philosopher Willard Van Orman Quine on the distinction between types and tokens. Quoting from Quine, "Es ist der Geist, der sich den Körper baut." Such is the 9-word inscription on a Harvard museum. The count is 9 because we count der both times. We are counting concrete physical objects, 9 in a row. When, on the other hand, statistics are compiled regarding students' vocabularies, a firm line is drawn at repetitions, no cheating. Such are two contrasting senses in which we use the word word. A word in the second sense is not a physical object, it's not a dribble of ink, it's not an incision in granite, it is rather an abstract object. In the second sense of the word word, it is not two words, der, that turn up in the inscription, but one word, der, that gets inscribed twice. Words in the first sense have come to be called tokens. Words in the second sense are called types. Now, the same points apply to relational models. Can we avoid Platonism by saying that the infinitude of complex models is an infinitude of types? Equating a highly complex, recursively structured model, which has never been physically realized, either in the brain or in society, equating that with a type does not avoid commitment to an abstract object. In fact, it's the opposite. A model construed as a type would have no location in space or time, even though its implementation in a society can be dated and located on a map, and its mental representation dated and located in a brain. Okay? So according to Katz, appealing to types will not help you escape from the dreaded Platonism. Is there some other way of escape? Are there alternatives to saying that the discrete infinity of language is an infinity of expression types? Could one say that the infinite collection in question consists of merely possible but largely unactualized sentence tokens? In other words, it's merely possible sentences which exhibit infinity. You know? So when we talk about the infinitude of language, we're not talking about actual sentences, we're talking about possible sentences. Well, being a good metaphysician, Katz has to ask, what is an unactualized possible sentence token? It's not something located in space or time, and it's not something that can be perceived, right? Not even in principle. Katz remarks that non-actual instantiation possibilia meaning things that are merely possible but not actual, non-actual instantiation possibilia are not dribbles of ink. They are not incisions in granite. They are not disturbances of the air. One could say that they're not brain processes either. And Katz goes on, having no location in space or time, non-actual instantiation possibilia qualify definitionally as abstract objects, just like types themselves. Katz's conclusion is that whether one construes the infinite collection of sentences as a collection of types or as a collection of possibilia, in either case, it's a collection of abstract objects. And note that the same applies to relational models theory. One could also argue that relational models theory should be a purely formal study with an abstract subject matter, because the relational models also exhibit discrete infinity. Now, earlier I mentioned performance limitations. Performance limitations, Katz points out, are no argument for the finitude of the relational models. Well, actually, Katz is talking about language, but the same point applies to the relational models. Performance limitations surely also apply to logic and mathematics, and performance limitations are not an argument for the finitude of logic or the finitude of mathematics. At the very least, the finite number of minds through cosmic history, as well as the temporal finitude of each mind, this means that there are deductions in logic and there are deductions in mathematics that will never be made. But those are valid deductions nonetheless. Performance limitations do not mean that logic and mathematics study finite objects only. They do not, these performance limitations do not mean that the set of all natural numbers is a finite set. To the contrary, the set of all natural numbers is infinite. And there is no need to study performance limitations within the fields of logic or mathematics. Performance limitations on the compounding of relational models also lie outside the study of the models themselves. And this brings us back to Alan Page Fiske. Fiske's innovation in anthropology is analogous to the Chomskyan revolution in linguistics. Fiske psychologized sociality, just as Chomsky psychologized language. And what this means is that Fiske showed how mental representations can play a central role in the coordination of social relations. And by doing that, Fiske made sociality less empirical in the sense of its involving mental processes, as opposed to directly observable actions and objects. However, in psychologizing sociality, Fiske also made progress toward understanding the infinitude of social structures. And all of this is analogous to Chomsky's work. Specifically, Fiske's appeal to four elementary discrete models made it possible to understand how recursive embedding enters into sociality. In order to have embedding, you have to be able to count elements using whole numbers. I can't say that one element is embedded in another unless I can count them using a whole number, such as 2. There are 2 levels here. One level is subordinate, the other is superordinate, right? Now, before relational models theory, social scientists could theorize about what accounts for social structure as such, or they could speak of the function of social structure as such. But social scientists could not count social structures, except intuitively and in isolated cases. So, for example, one might speak of Iroquois social structure. And it's countable because the same structure could appear in a different society, and one could count the number of its occurrences. But that wouldn't be a general theory or a general method for counting social structures. And what's more, it would be a matter of intuition as to where Iroquois social structure ends and some other social structure picks up, as in the case of interactions between Iroquois and non-Iroquois, or in changes to Iroquois society over time. So before relational models theory, there was no wholly objective way of counting social structures, even in isolated cases. And so long as there was no general objective method for counting social structures, one couldn't speak of recursion, because one could not distinguish the embedded object from the embedding framework. So the contribution that Fiske made was to propose atomic social structures which are culturally invariant. So now social structures can be objectively counted. In other words, Fiske recognized the particulate nature of social cognition. But in taking that step, Fiske moved away from the immediately observable, namely the social relations themselves, in the direction of something more abstract, namely internal representations. Now you can see that considerations that are analogous to the ones raised by Katz might lead one to wonder if Fiske has really gone far enough. Maybe an even less empirical approach is needed to account for the discrete infinity of social structures. Maybe a Platonist conception of the relational models is necessary. All right. Chomsky himself is not happy about this line of argument. He's been resistant to it to various degrees. Chomsky has suggested that maybe, in some cases, when we speak of the infinite, that's really just an abbreviated way of speaking of something finite. And in defending the view that language is an object of empirical study, Chomsky has defended that sort of possibility. So Chomsky maintains that even though discrete infinity is an elementary fact about the language faculty, the phrase discrete infinity does not refer to something of any ontological status. In other words, it doesn't refer to anything that reveals the structure of the world. Here's a quote from Chomsky on this issue from his article Derivation by Phase. The sentences generated by a grammar are not entities with some ontological status. They are introduced to simplify talk about properties of the language faculty and the particular grammar in question, the particular language. And they can be eliminated in favor of internalist notions. In other words, they can be eliminated in favor of discussing just what goes inside, what is going on inside the person's head. Similarly, a study of the solar system could introduce the notion HT, which is the set of possible trajectories of Halley's comet within the solar system. And note that that would be an infinite set because there are infinitely many possible trajectories. Or the studies of motor organization or visual perception could introduce the notions of the set of all possible plans for moving the arm, which is also an infinite set, or the set of visual images for cats, which is an infinite set. But these studies do not postulate weird entities. By weird, he means outside space and time. No. They do not postulate weird entities, apart from planets, comets, neurons, cats. There is no Platonism introduced, only biological entities and their properties. And you wonder if cats is a reference to our friend Gerald. Okay, bad joke. Moving along. I said. Here we are. Now for Chomsky, language is the infinite use of finite means, which is reputedly a quote from Wilhelm von Humboldt, although I've never been able to find the original source. Humboldt being a very early linguist who lived circa 1800. Now, according to Gerald Katz, to speak of the infinite use of finite means is paradoxical. Even if one posits merely possible entities, these possibilia must have some sort of reality. In other words, language is infinite, period. Now, the cases of Halley's comet and limb movement, if those are to be successful counterexamples to Katz, they have to show how talk of an infinitude is really just talk of something finite. Now, do they show this? Consider the case of the comet. one postulates the solar system. The solar system is a finite number of objects occupying a finite space through a finite period of time. Yeah, so it's all finite in some sense. Nonetheless, one can also speak of an infinite collection of possible comet trajectories. But this sort of talk commits one to nothing more than the finite resources just stated, or that's what Chomsky is claiming. The same holds for possible arm movements. One can move one's arm an infinite number of ways. But saying so does not commit one to the existence of anything more than one's arm, the brain controlling the arm, and the finite space in which the arm is moving, which is a finite collection of things. Okay? Or at least that's what Chomsky seems to be saying. However, the infinitude of, this is an objection to Chomsky, the infinitude of possible trajectories of Halley's comet, in fact, does require infinite resources. Namely, the fact that even a finite region of space-time consists of an infinitude of points. If it should turn out that space-time is not infinitely divisible, in that case, the collection of possible comet trajectories will turn out to be finite, given a finite volume of space and a finite length of time. Hence, the case of Halley's comet does not illustrate the infinite use of finite means, but instead it illustrates the infinite use of infinite means, using the word use loosely. And an analogous point applies to the case of limb movement. There are infinitely many possible ways to move one's arm in a finite space. But this is because there are infinite resources, namely the infinitely many subspaces which compose any given finite region of space. Which is to say, there's an infinitude of actual things in either of these two cases, an infinitude of actuals. Infinite potential here depends upon an infinite actuality. But in the case of language, understood biologically as a feature of the brain, there's no infinite number of relevant actuals. There's no infinity of points in any pertinent sense. There's no infinity of subspaces in any pertinent sense. So in contrast to the case of the comet and the case of limb movement, the resources of the biological language faculty are finite, not infinite. And in fact, elsewhere, Chomsky has correctly contrasted the discrete infinity of language, on the one hand, with the continuous infinity, on the other hand, of an infinitely divisible bounded space. And part of that contrast is the difference between actual infinity, because a finite space consists of infinitely many actual points, versus an unactualized infinity, because a non-actual infinitude potentially resulting from recursion is something abstract. However, in Chomsky's examples of Halley's comet and limb movement, he overlooks that distinction. In other words, he overlooks the distinction between natural numbers and real numbers. When we talk about the discrete infinity of language, we're talking about natural numbers. When we talk about the infinitely many trajectories of Halley's comet, we're talking about real numbers because we're talking about divisibility. So it's not the same thing. Now, basically, the same observation applies to Chomsky's using vision as an example, as in the case of cat vision or bee vision. Models of vision, allowing for an infinite range of images, posit pixels, and each pixel can take an infinite range of values. So each pixel is understood as a continuously random variable. According to the book that you see here, Computational Vision, each pixel is understood as a continuously random variable. In other words, a variable that can take an infinite number of values. Here too, we have the potentially infinite use of infinite means, not the infinite use of finite means. So I conclude that Chomsky's examples, Halley's comet, limb movement, vision, these examples are not convincing because they're not analogous to the case of language. The infinitude in those cases is the infinitude of real numbers, not the infinitude of natural numbers. These cases, vision, Halley's comet, and so forth, they are also disanalogous to the collection of the relational models. The infinity of the relational models is also the infinite use of finite means, if we're going to avoid Platonism. Now, the upshot is that we do not find here a good reason to think that Platonism has been avoided in the case of language or in the case of the relational models. The examples of Halley's comet and so forth do not illustrate Humboldt's famous phrase, the infinite use of finite means. Now, I say so far because those are not all of Chomsky's examples. He has one more illustration. This continues Chomsky's quote that we started earlier. One of the properties of Peano's axioms, which Chomsky refers to as PA, Peano's axioms, is that they generate the proof P of 2 plus 2 equals 4. But the axioms do not generate the proof P prime of 2 plus 2 equals 7. No, they'd better not, because it's false that 2 plus 2 equals 7. So we can speak freely of the property generable by Peano's axioms. This property holds of P, it does not hold of P prime. And derivatively, of lines of generable proofs, in other words, theorems, and the set of theorems. But we can do that without postulating any entities beyond Peano's axioms and the properties of those axioms. In other words, Peano's axioms are a finite set. But we can ascribe properties to an infinite number of entities as a means of speaking of this finite set of axioms. So Chomsky is saying that the language faculty is analogous to Peano's axioms. Linguistic competence in the brain is something finite, like Peano's axioms, and nonetheless it defines an infinite set. In the case of Peano's axioms, it defines an infinite set of mathematical formulae. In the case of language, an infinite set of sentences. Okay. Now, here are, hold on a second. Yeah. Peano's axioms were actually discovered by Ricard Dedekind, and they were later formulated with greater precision by Giuseppe Peano, and they've come to be known somewhat unfairly as Peano's axioms. And here they are. You can freeze the movie and look those over if you like. Chomsky's point is that just as talk of the infinite collection of proofs, which can be generated by Peano's axioms, is really just shorthand for talking about the finite set of postulates 1 through 5. Likewise, speaking of an infinite set of sentences for some natural language is really just shorthand for talk of the properties of the finite language faculty in the brain. Also, likewise, in Chomskyan fashion, one might be inclined to argue that talk of an infinite collection of relational models is really just shorthand for referring to the properties of the finite resources of the human mind. Okay. Now, Paul Postal, there he is. Paul Postal also has an objection to this. Postal himself is a Platonist. He's a philosopher and also a linguist, primarily a linguist. Postal has pointed out, in defense of linguistic Platonism, that axioms 1 through 5 are statements. And here in particular, he's not only defending linguistic Platonism, he's defending mathematical Platonism. The axioms are statements, and because they are statements, they can be true or false. They are useful to mathematicians, presumably because they're true. More specifically, they are true statements about the natural numbers. In order for there to be true statements about the natural numbers must exist. This means that when we talk about numbers, we're talking about abstract entities. In other words, Platonic forms. There must be something in order for the statements to be true of something. But in that case, Peano's axioms are not a good illustration of why Platonism is unnecessary. They do not show that one can do without weird entities outside of space and time. The appeal to Peano's axioms, at least on the face of it, appears to support Platonism rather than undermining it. Now, Chomsky, let me summarize what we've gone through here. Chomsky has offered two sorts of examples which are supposed to show that when we talk of an infinite collection, this is sometimes just a convenient way of speaking about something finite. However, some of Chomsky's examples turn out to be disanalogous to language in crucial ways. And more to our current purposes, they turn out to be disanalogous to the relational models. So vision and movement through space are not convincing examples because they illustrate the infinite use of infinite means rather than the infinite use of finite means. And that's because they are cases in which the infinity in potential results from the infinite divisibility of some continuous space, a vector space in the case of vision. And the case of Peano's axioms is different because the axioms are a finite list of statements. However, the axioms are only of use to mathematicians because they express truths. And they express truths about something infinite, namely the set of natural numbers. So Peano's axioms turn out to be an illustration of commitment to an infinite abstract entity after all, and they're not a counterexample to Platonism. It would appear that if the discrete infinity of language is to be a good argument for sentences being Platonic forms, then we also have a good analogous argument for the relational models being Platonic forms. So that what originally looked like anthropology has turned out to be an abstract formal science like mathematics. Because the relational models also exhibit discrete infinity, even though the resources of the brain are finite. In other words, the models constitute an infinite collection of abstract objects. Well, okay, so there's a conflict, or at least an apparent conflict, between these arguments for Platonism on the one hand and the biophysical approach to numbers, language, and sociality on the other. The biophysical approach being the approach that posits computations in the head. Now, a pretty simple and attractive way of escaping from all this, or reconciling the two approaches, is to say that the biophysical study addresses mental representations, which in fact are brain states. On the other hand, the formal study, the abstract study, concerns these Platonic forms. The mental representations represent the Platonic forms. The brain states refer to the Platonic forms. In other words, the mind, which is not abstract, it's concrete, the mind grasps the Platonic forms. In other words, the models are abstract objects grasped by the mind because of biological processes in the brain. The representations in the brain mind are finite in number, but some of them designate a subset of infinitely many abstract objects. Furthermore, Chomsky has noted that even if there is a good argument for natural languages being Platonic forms, that a psychological or biological branch of linguistics would still be necessary, because it's possible that there would be a mismatch between mental representation and Platonic form. So, quoting Chomsky, the best theory of the internal language, that's the language viewed as something inside the head, language viewed as a computational system. The best theory of the internal language, of what this person actually knows, might not be the best theory of what is selected on some grounds to be Platonistic English. This would follow if the evidence stipulated to be relevant to identifying a certain Platonistic language as Platonistic English is distinct from the evidence that bears on the theory of the internal language actually represented in the mind-brains of speakers of English, or if some novel canons are adopted for interpreting evidence. And this is what we find in relational models theory, in fact. The cognitive and presumably ultimately neurophysical realization of human knowledge of the models may fall short of what the models are in themselves. And this point is implicit in Chomsky's discussion, which we reviewed earlier, of how unbounded counting might be an offshoot of the computational core of language. So, quoting Chomsky some more, there are properties of the language faculty which are not found elsewhere, not only in the human mind, but in other biological organisms as far as we know. For example, the most elementary property of the language faculty is the property of discrete infinity. This property is virtually unknown in the biological world. There are plenty of continuous systems. That's why Halley's Comet was not a good example, because space is continuous. There are plenty of continuous systems. There are plenty of finite systems. But try to find a system of discrete infinity. The only other one that anybody knows about is the arithmetical capacity, which could well be some offshoot of the language capacity. Now, there's no reason to think that Chomsky is denying that there are purely formal mathematical studies. In making this remark, he's not denying that there can be a purely a priori, in other words, non-empirical study of mathematics. Nor is there any suggestion here that numbers are not Platonic forms. What Chomsky is suggesting is that a psychological study, he's suggesting a psychological study into how humans are able to mentally represent numbers. And in fact, that proposed psychological study would fall under the umbrella term biolinguistics. If Chomsky's suggestion is correct about the computational core of language crucially entering into unbounded counting. So biolinguistics can include inquiry into how the human mind forms mental representations of abstract objects. Now, this conception of biolinguistics is consistent with Katz's proposal that languages are Platonic forms. Biolinguistics would then be the study of how the empirical and concrete human brain mind represents these abstract objects. And this would be analogous to the claim that Fiske's cognitive anthropology, his relational models theory, is a study of how the mind forms representations, namely the relational models schemata. And these representations would then represent abstract objects outside of space and time. The finitude of the brain mind would mean that only finitely many abstract objects are represented. But the abstract objects themselves would constitute an infinite collection. And I'm not aware of any contradiction in this. So you would have a kind of division of labor where the biophysical study would be of mental representation and the a priori abstract study would be of the Platonic forms, the corresponding Platonic forms. And this raises some pretty deep questions about knowledge. How is the mind able to grasp something abstract? Is it true, as the ancient Greeks thought, that knowledge is a relation of like to like, that there has to be some kind of analogy or similarity or sameness between the mind on the one hand and the abstract object on the other in order for the mind to grasp the abstract object? That is a really interesting question, and I'm not even aware of whether people address that sort of question anymore. Now, that's a good example of the sort of question that the ancient Greeks loved. I mean, they would be all over that question, and nowadays it's pretty much ignored, even though the question is still there. It's still an interesting question. How does the mind grasp an abstract object? Is it because of some principle akin to the ancient Greek principle of like is known by like? I really don't know. A very interesting paper topic, by the way, would be to focus on whether the discrete infinity of any of these things, language, numbers, or the relational models, whether the discrete infinity of any of these things necessarily implies Platonism. And yeah, that would be a great paper. Okay. Now, for next week, I want you to read the chapter by Paul Postel. One thing that Katz and Postel have in common, apart from the fact that they're both Platonists, well, Katz is dead, but when Katz was alive, he was a Platonist. One thing that Katz and Postel have in common, aside from both being Platonists, is that they are both very critical of a computational approach to the mind. And in the chapter by Postel that you'll be reading for next week, Postel is raising an objection to a computational approach to the mind. All right? And until then, I'll see you, and please contact me if you have any questions or anything. Bye for now.